Hi, everyone again. My name is Weiyuan. I'm a GDE in Google Cloud. And actually very different from my domain. I'm going to be speaking about this very interesting and very wacky topic, something I worked on quite some time ago. So name of our topic is implementing trigonometry in SCSS. I hope most of you remember what exactly is trigonometry. I'll be recapping a little bit later on. It'll be probably like an old friend that you haven't seen in quite a long while. So yeah, let's get started. Okay, so just want to talk about the problem statement. What exactly was I trying to solve? Why was there a need for trigonometry? Okay, so the idea was basically this. I wanted to recreate this moving image as you see over here within one of our web applications. Okay, so the larger context of this problem was within this site called Soompi. For those who don't know what Soompi is, it's a K-pop publication news site. There are other sites out there like all K-pop and things like that as well. So Soompi was one of them where you can actually use the site to look at the latest news in regards to K-pop related stuff, K-dramas and things like that. Okay, so part of what we had to do was that we were looking at rewriting the entire application from a WordPress application over to a service-oriented architecture, multiple applications, some on the front end, back end, mobile applications. Okay, so the idea is that this basically this application itself, when we rewrote this, we had a redesign, a rehaul of the application. So this animation, this loader, in fact, this is a loader animation, was used as part of our redesign. Okay, so we had to be able to add this within our site. Okay, so I think basically just from a very brief overview, right? Or once you look at this, right, you might already have some ideas on how to resolve it. So I think we can talk about a few solutions on this. Okay. Okay, so basically many different solutions on how you can solve this problem, or rather emulate, solve that issue you saw earlier on. Of course, spoiler in title, yes, we went with computing our own trigonometric formulas in SCSS. But let's talk a bit about why we didn't went with the other solutions. Okay, let's start with the first and very, very obvious solution. If you're hosting a web application, usually you have some image assets. So PNG files, JPEG files. If you have a moving image, you definitely will use something like GIFs. Okay, so how do you implement this in your web application? Well, just make sure that you have the origin GIF file. Make sure you host the whole file somewhere. Let's say if you host it within a bucket, or maybe bundled together with your server application. If you're delivering it directly from there. And then within your HTML, just load the GIF asset, and basically that's it. You're done. Okay, so basically this is the result you should get. So right now within this, is in the slide that I'm sharing right now, is actually a web application. It's not a Google Slides. So this is using Review.js, and basically the loading of this image that you see over here is basically what we are trying to solve. As long as you have the GIF, you just load it, and this is what you get. Okay, but already from here, you might already start sensing that there are some problems here. Okay, but let's first talk about why we want to use solutions like this. Okay, the very clear-cut solution, or rather why we want to use this solution, is because it's plug and play. It's very simple. You have the image asset, you just reference it as part of an image tag in your site, and that's it. You're done. There's no additional engineering requirements towards getting this out. A very simple solution indeed. Okay, but why didn't we went ahead with a solution like this? One of the big things that we were discussing about within the team was that the file size of this GIF file was really, really big. And let me just show you. So this is when you load the site from the console, you can see that the actual file itself is 97.5 kilobytes. So if I compare this to, let's say in our case, we're writing our web application, our JavaScript, as well as other CSS assets, the size of those files were already comparable to this size or even smaller. So this means that to load a simple loader animation in our web application, we're actually sort of paying a larger price for that by having to load even more assets just for this simple thing. So it didn't felt like a very good solution because of that. Of course, you can play around with the balance by, let's say if you want to reduce the file size, Maybe you can reduce the amount of frames in the GIF. But this would mean that you won't get a very realistic animation. It might look very ugly. For user experience, it may not be optimal. So again, not something that we want. Okay, and as with all images in web applications, resizing it's bad. You can of course use things like source sets to solve the problem, but this would mean now you need multiple image assets, each for each different size. And then admittedly, as a engineer, I have no idea on how I can use Photoshop. So if I need to be able to, let's say if I want to change the color, I have to go to my designer and ask them to, change it for me. And then now you have like all these additional steps to follow just to change, a simple asset in the page. Okay, so because of these reasons, we felt like this wasn't a good solution. Okay, so what other solutions are there out there for us to use? One other solution that our designers proposed to us was, why not use something like an animation library? Okay, so let me touch a little bit more on that. The idea is basically, instead of trying to engineer a solution ourselves, get the open source solutions or other solutions out there and use those solutions. Okay, so there's this library out there that's called Lotte files. Essentially, they serve many different platforms. You can see over here at the bottom. There's plugins available for web, iOS, Android, Flutter, React Native, so on and so forth. So basically, you are able to add these plugins in different applications, and the idea is that you just need to use this Lotte files, right, to generate a JSON representation of your animation, and then load both this plugin as well as that JSON file into your application. Okay, so that's exactly what, this is the methodology. Just create an animation, get a JSON file, load the library, load the JSON file in the web application, and it's done. Okay, so what exactly is it? So you can see over here, I have a CodePen widget over here. You can see that basically I'm doing exactly what I mentioned just now. I have a script asset, a script tag, loading the asset for the Lotte player, as well as the component itself based off this JavaScript file. So yeah, over here, I'm just loading the JSON file for this, and you can see over here that the animation, in fact, is quite nice. If you compare it to the GIF earlier on, it's actually, it looks more realistic. So it seems like already a better solution as compared to GIFs. Okay. Okay, so why would we want to go with this using an animation library like this? Okay, firstly, the one big thing just now that we mentioned about GIFs is the file size. Okay, the file size for this, take a look at this. It's really, really small. The JSON file is 1.2 kilobytes. Just now, what we had was 97 kilobytes. So you can really see it's like a huge difference as compared to before. Okay, and similar to using a GIF, it's also simple to use. For the last solution, we are putting in the reference to that GIF asset. Over here, we're just referencing the JSON file itself. So it's not very complicated to implement within your web application. And one big thing that really appealed and stand out to us was that because we were rewriting the Soupy application to work across multiple platforms, not just the front end, but also for mobile applications. And because the design were very similar, the same loaded animation was used consistently. For the mobile devices, the mobile applications, they could use the same JSON file to emulate this animation. And then from a web application standpoint, we can also reuse this same asset. So this already, it's a very big benefit for us. Okay, but obviously we didn't went with this solution, as mentioned again in the title. So why did we went that way? Again, like the GIF itself, you need some form of you need Photoshop, you need those skills to be able to create that animation. Again, this is some skill that I don't directly have, as well as the core engineering team we didn't have at that point. So there's still some reliance on the designer teams, to create these assets. Initialization cost. Initialization cost, here I'm referring to the JavaScript library itself, is actually quite high. So you can see over here that the minified file, it's actually for this JavaScript asset is 58 kilobytes. So compare this again to the GIF file earlier on, 97 kilobytes. It's kind of close in magnitude. So the thing over here is that if I'm only using this library for only one animation, it may not be actually worth it. We're not really using this for the economies of scale, but we are just doing it for one single animation. So it doesn't, and at the point of time, that was our only use case. So it didn't feel like a very prudent choice from there. Okay, so we didn't went ahead with this. Let's look at other solutions, or the solution that we decided to go with, engineering it ourselves. Why not? Let's do it in CSS and get that the final product out ourselves. So in the middle of work, I was looking up on this fun story lah. I was looking up in Wikipedia on trigonometry because it's been 15 years since my secondary school, high school, and I haven't touched on trigonometry for many years. So I was actually looking up on Wikipedia on studying up the topics again, and this caught the attention of my manager, who was asking me, why are you looking up on trigonometry? It's nothing to do with web development or backend or cloud. It was a very odd occurrence, but things like this do happen in our different workplaces. Okay, so let's look at the solution over here. How can we do it in CSS? Okay, so what we want to do over here, in fact, for a CSS-based solution, is implement that styling itself in your style sheets. And once you have the style configurations, load those style sheets into a web application. That should be it, right? It's a very, this is how we serve web applications nowadays. So this should be a very simplistic way, again, of how you can serve your solution. Okay, so let's break down the problem a little bit, okay? Because just now, as you saw the animation itself, okay, let me just scroll backwards to the animation and describe about this. Okay. Ooh. Okay, so let's break down this problem, this animation over here. If you want to do this in CSS, right, we can actually see this in 4 different parts. So if we break down this problem, okay, the first part, the most obvious part, is the hexagon. We need to find some way to draw the hexagon in CSS. Okay. The second thing is animation. You need to be able to do some form of animation in terms of this rotation animation. Okay. Third problem is the hexagon of different sizes. Okay. We're not just looking at a hard-coded and static sized hexagon. We are looking at 4 different hexagons of 4 different sizes. And the same thing goes for animations. You need to cater for both a clockwise rotation as well as an anti-clockwise rotation. Although both of them are linear, so that property is the same. But yeah, different directions. We need to cater for that. Okay, so let's go back. Okay, so as I've mentioned, breaking down the problem, you get this 4 different perspectives, or 4 different subsets of a problem over here. Okay, so let's look at each of these problems and see, which one is understand how we can solve each of them. I'm going to skip hexagon first because it's slightly complicated to do. The others are a bit more clear-cut. So rotation animation, if you search online, there are already guides on how you can do that. Basically, you just need to put in the proper configurations for the keyframes and get that done. Okay, so that's very simplistic. Hexagons of different sizes. Okay, assuming you are able to draw the hexagon, all you need to do is just use some CSS property to do the scaling of the size of a hexagon. And immediately you should be able to get your solution as well. So again, this is a simple problem. And the last subset of the problems, a clockwise and anti-clockwise rotation. So this is part of the problem for solving for animation. If you can solve for a clockwise rotation, you just need to reverse some of the properties. You should get anti-clockwise. So again, this is an easy problem to solve. So we end up with one last, the bigger subset, or this largest problem to solve, within here. How do you exactly draw a hexagon in CSS? I mean, drawing a square is simple. Drawing a rectangle is also simple. Just use a div, put the border, change to a different size is doable. Drawing a circle, using border radius, that's doable as well. But a shape of, regular, more than 4 sides, right? It's actually not something that's intuitive to do. We actually came up with this solution. So there's actually a very quick way of doing this. If you want to draw a hexagon in using CSS, what you need to do, take a div, okay, and only draw the top and bottom borders, and then use the pseudo, before a pseudo selector, rotate 60 degrees, draw the top and bottom, okay, and same for the after, but you rotate negative 60 degrees instead. So you should be able to get you should get all 3 of the top, bottom, rotated to the left, top, bottom, and then the other way as well. So you should be able to get 6 sides directly from there. And because each of the sides just deviate away from each of the sides by 60 degrees, so that should already give you the final solution of being able to draw a hexagon. So is it really that simple though? Now that I'm mentioning it, that means we have solved the whole thing, right? But I did say that this is a solution in SCSS. Okay, so here's what exactly happened once we did this. So fun stuff in engineering, usually things doesn't go your way. Problem over here is that one thing that we learned is that we sort of had assumptions of that this shape is like a square. For a square, the length is equal to the breadth or the height width. So the idea of the hexagon is that actually that's not the case. I'm thinking that the height of the hexagon itself is equivalent to each of the sides, but because there's 6 sides, technically speaking, it should be shorter. So we need to find some way to compute and be able to draw, reduce the length of each of these sides and be able to compute, based on how big my hexagon is and get the proper length of each of these sides. Okay, so let's re-examine this hexagon. So this is the fun part about trigonometry. Hold your seatbelts. This is going to be a mathematical part. I'm just going to say, basically in trigonometry, there's the adjacent angle and there's also the 3 sides, basically your adjacent side, hypotenuse side, as well as the opposite side. So opposite is just opposite from the angle, adjacent, beside the angle, hypotenuse is the long side of this right-angled triangle. Okay, yeah, this is only applicable to right-angled triangles. Okay, hopefully some of you might start to have memories, hopefully good memories of this cheat code that usually we use in school called Tuakaso. So basically this would represent the formula, the 3 different trigonometric formulas that we use to solve for trigonometry. So I'll touch on a little bit more on that later on. Okay, so now that we know that we need to do some form of mathematics in this solution, right, to compute each of the sides, we can't just do that in CSS. It's not supported in CSS at that point. So we need to use some form of compiled script to be able to do this. So in fact, you can do that if you're already using something like SCSS or using SCS essentially. Okay, so using an Scss syntax. Okay, so how do you do this in SCS? Okay, so let's go backwards and look at the few trigonometric formulas again. Okay, Tuakaso. And let's try and see, try and fit together the formulas with our problem statement over here and see what formula we should use. Okay, so for tangent, right? Okay, tangent. So Tuakaso itself, again, the cheat code is basically T equals to tangent, and then O is opposite, A is adjacent, and then C is cosine over here. AH, yeah, is in very clear cut as well, adjacent, hypotenuse, and same thing for sine with opposite of hypotenuse. Okay, so basically the 3 formulas that you'll get over here is the tangent of over here you can see over here, the tangent of this right-angled triangle over here, 30 degrees, is equivalent to the opposite side divided by the adjacent side. Okay, and okay, I'm not going to drone on this too much, but let me just pull out the other 2 formulas. So basically the entire thing of Tuakaso. Okay, so these are the 3 formulas that we have over here that we can apply on this right-angled triangle. Okay, but what exactly, or which formula should we apply for this solution? I mean, I can implement any of this, but we need to select the right one. Okay, so let's first look at this entire formula. If you look at the cosine formula, you can see that, okay, we know that we intend to implement the cosine function. We know this is a known value. The adjacent side, okay, adjacent side over here is also a known value because we know the height of our hexagon itself. Over here, what we are trying to do is to compute each of these sides over here, which is basically 2 of O. Okay, but the thing over here is that you can see that we have 2 knowns, and we have, so known number 1, known variable number 2, hypotenuse is unknown. But the idea is that we're not trying to compute for the hypotenuse here. So let's kick out this solution, this one formula, because we know that definitely that's not going to get us the solution that we want. Okay, so now we have the tangent formula and sine formula remaining. Okay, let's compare these 2 formulas. So if you look at the sine formula, okay, so again, we want to implement the sine function. We will know this value. Opposite side is what we want. But again, hypotenuse side is also unknown. So if you have 2 unknowns on one side and 1 known variable on this side, you won't be able to compute one of these unknown values. So this is something that likely wouldn't work really. Okay, so we have this one single formula remaining. So tangent of 30 degrees, this is a known value. Opposite side is what we want. The adjacent side is what we already know. Okay, so basically this should be able to get us to what we need. So we just need to manipulate the formula a little bit. You can see that you can actually compute the value of O directly from this formula. Okay, Okay, but this one would bring us to a further question over here. How do you exactly implement tangent function? So again, this is not supported in CSS today. If you have used SCSS before, you have used SES before, right? You know that there's no functions for a sine formula, cosine formula, and tangent. So that's where like big problems again. How do you exactly implement this very, I guess, somewhat arbitrary formula that most of us probably wouldn't even touch on a day-to-day basis in code? Uh, Math time. This is Maclaurin series, Maclaurin expansion. I mean, basically you should be able to compute, let's say, the value of sine using this summation formula over here, where this would tend over to infinity. So x minus x here refer to the degree in radians, minus x to the power 3 over 3 factorial plus x to x power 5 over 5 factorial, so on and so forth until infinity. Okay, so I mean, there's some math formula itself. I'll touch on a little bit about the infinity portion later. We are not going to calculate the infinity, of course, because that would mean that our build process will never end. Of course, we will tend to like some limit. Okay, but this is actually something that we can use to solve our problem. Okay, to implement for sine formula. But some of you might be thinking again, Weiyuan, I thought you were talking about getting a tangent formula over here. Like we need the tangent functionality, right? Why are we talking about the sine? So this is part of me when I was looking on how to implement the tangent function, where I found out that to implement the tangent function is basically just you have to implement both the sine and cosine function, okay, to get it. So sine of a certain radian over cosine is equivalent to the tangent of that same angle. Okay, then now your second question might be, okay, so I know that it's a function, tangent is a function of sine and cosine, but that means I also need to compute cosine, right? It's again another like unknown that we have over here. So yeah, for those who are already catching on like to my drift over here, you can implement cosine with sine as well. So now it goes back to like the earlier, the comparison that we had. In fact, the idea is that the moment you implement sine function, you just need to change the parameters going into the function. You should be able to get the cosine function and then use that, both of these functionalities, to implement your tangent function. Okay, so this should get us to where we need to compute the opposite side. Okay, so let's dive in a little bit deeper about this to this formula itself. So how do you exactly implement this entire formula in SCSS in code, essentially? So if we need to break this down, right? Firstly, let's look at some of the portions of this formula over here. How do you calculate for factorial? Factorial is really simple. 3 factorial is essentially equivalent to 1 multiplied by 2 multiplied by 3. If it's 5 factorial, it's 1 times 2 times 3 times 4 times 5. Okay, 7 is again just the same thing, so on and so forth. So, I mean, if you're just writing this in code, it's like you can see over here in Scss Syntax, basically just a simple for loop with a start and end value, and then basically just loop all the way until you get to the end. Okay, you can actually see over here, usually for factorial, right, you're only concerned about the end value. So let me go back to the formula. You can see over here 3 factorial. We are only concerned on the last value, which is 3. Actually, we don't even concern ourselves with the first value. So actually, over here in our factorial function, we actually optimize it a little bit by adding some starting value and some current value. So this was an optimization to allow us to not perform or recompute certain values again. Because if you go back and look at the formula, 3 factorial, okay, 3 factorial, we can't really pre-compute this beforehand, but we know that 3 factorial is 1 times 2 times 3, okay? 5 factorial, right? If I'm calculating, let's say I'm going through each of the loops for each of these values, right? The first loop, first iteration or second iteration itself, you'll get this value. The third iteration, you will get x to the power 5 over 5 factorial. And 5 factorial itself, actually, if you think about it deeper, right? It's actually just 3 factorial multiplied by 4 multiplied by 5, okay? And the same thing goes for 7 factorial. It's just 5 factorial multiplied by 6 multiplied by 7. So if I've already computed the result in the last iteration of this formula, why not I just use the same results and continue on the multiplication from there? Okay, so that's what we did over here. We just allow the user to be able, or rather the formula itself, to implement and add in like some value that they can continue the computation at, and multiply like whatever current computed or aggregated value that we are also currently at. Okay, so this will allow us to make the build process a little bit faster. And that's why we did the same thing for the x to the power of some value. If it's x to the power 3, you just need to use the last value and just multiply it by x to the power of 2 again, again and again for each of these iterations. Okay, so this is for optimization of power as well as factorial. Now, how do we implement this entire sine formula? I think that is also another interesting part. Boom, we have this entire, okay, I'm not going to go through it line by line, but essentially the main portion from line 20 to line 37 is the entire formula itself. I have some corner cases from line 7 to line 17, which is essentially, if it's for some of y'all who are familiar with the trigonometric formulas, if it's at certain values, sine of pi or something like that, you'll be able to get either the value of 0 or value of 1. So you don't really need to go through this computation, this iterative computation to get your results. In fact, you can just return these known values right away. Okay, and you can actually see over here that on line 29, I have this value of sine iteration for this loop. So if I go back to this summation formula, you can see that this actually sums up to infinity. So I'm supposed to do this until infinity. But in the case of us, using this in a production setup, to generate our CSS styles configuration, what we found was that we just need to get to a high enough number such that the deviation itself is so small that you can't actually see it on any screen. So it turns out that the value of around 10 to 11 was actually big enough, or rather the deviation was so small that even if you have like a monitor at 4K size, right, the difference is 1 single pixel. So it's so small that you can't actually see it. So that's why we decided, okay, yeah, that's enough. We just need to get it to this a certain point where it's accurate enough to do this. Of course, if we need to update this in the future for even larger screens, we can do that. Okay, so this is how we solve it for sine. So as I mentioned, once you solve for sine, you get your cosine formula, which is basically a function of sine, and then you get back tangent, which is, again, based on sine and cosine. So almost happy ending, we have gotten most of what we have over here. Okay, and basically we have our tangent function. We can just use it to compute the value of O, which is half of each of the sides of the hexagon. Okay, so once we plug it in, you can see I actually have those the functions written over here for factorial, for sine, cosine, tangent, and then some of the properties for the animations. Okay, you can see over here that basically I'm not all of this goes into computing for the hexagon class over here in the end, as well as in relation to the size to scale it up and down. Okay, and it's a lot more beautiful as compared to our the GIF, right, where you saw, sorry, not the GIF, the earlier solution where you saw that the length of each of the sides were jutting out, they were longer than expected. Okay, so this is exactly the result that we need. Okay, let's touch a bit. So I've talked about the entire solution for a very long time, but I want to talk a bit about the reasons, why should we use this? One big reason, it's a far cry from both the animation library as well as the GIF solution. The generated CSS, the minified generated CSS is just less than 1 kilobytes, 897 bytes. Far cry, a much better solution in terms of if you're concerned about file sizes overall. Okay, so this is a very, very good solution. Okay, but I've been asked, I've talked about this and discussed it a few times. Some people have actually asked me, why not use something like SVG? If you can generate the CSS properties for drawing this hexagon animation, why not implement it in SVG? And basically, SVG is our vector graphics. You should be able to have all those benefits of being able to generate it in CSS configuration, as well as not having the disadvantages of the GIF where you can't resize it properly, or rather when you scale it right, the resolution might go out of whack. So yeah, SVG actually it's actually quite a viable solution. Okay, fun fact over here, the SVG is used by 29.7% of all websites today. This is from W3 Text. You can search for this online. Quite a widely used asset nowadays. So in fact, it's also doable. You just need to reuse the same formula to be able to get your sine, cosine, tangent, and be able to compute the values out from there. And you can see over here that this entire thing, there's not much. I'm not really implementing any CSS here. In fact, everything is done in this SVG configuration over here. You can see over here each of the 4 polygons for each of the hexagons, and animate transform tag over here for the property to do the animation. Okay, so this is also another viable solution. In fact, Okay, again, this is a web application, the slides that I'm presenting on. So you can see that the SVG, when you put it here, it's quite good. I mean, in fact, I can scale it up and down. The resolution should not change. Sorry, the resolution itself should be still quite clear. Okay, and if I compare it to the SCSS solution, you can see that it's even better in terms of file size, 704 bytes. So it's, again, very viable solution. But we didn't went with this because it felt like an additional build process that you need to put in. You know, for SaaS, right? You can, most of us usually, or I would think that for most web developers, you will already have some form of build pipeline that goes around, you know, running your compiling your SaaS into the CSS style sheets. But for SVG, right, this would mean you need to, as part of a build process, you need to put in some form of shell script to be able to, you know, implement your sine, cosine, tangent formula, and then use it to create the actual SVG asset. So this is something that not very widely used case today, and probably is going to create like more issues for you, and you can't reuse the code as well. So that's why we felt that it was still more suitable to do it in SaaS rather than, you know, creating your own scripts to generate this SVG file. Okay, another fun portion of me writing these functions. You know, we have this sine function, cosine function, tangent function. Some of y'all might be asking, right? You know, it seems like you're writing, like you're implementing this logic in SAS. And one of the things we don't ask about ourselves, like, you know, mostly, right, it's, you know, when you're implementing CSS configuration is no one writes unit tests for CSS. It's like usually what happens is that you put a style in, it loads, it looks good, that's your validation. Like there's no, it's configuration. You don't test for configuration. But the problem here is that for SAS, you can write like logic in, you can create functions, compute some form of result out. So there is some form of computation here, but it isn't actually kind of mainstream to do testing. So I was thinking to myself, actually, this is something that we really need to test for if we want to make sure that this code doesn't break, you know, as, you know, our new developers join into a project and add in new functionalities, if they're reusing the sine function or fixing it. So that's something that we need to be concerned about. Okay, so just one more thing to introduce to you guys. You can search up on this library called True by this company called Oddbird. You can use their library to be able to run unit tests on your SAS code. Okay, so it itself is very simple. You just need to have some assertions. In this case, I'm testing my factorial function with some expected result. Okay, so very simple, and yeah, should be able to run it in your test in your client, and basically you should be able to get the results if it's correct. If it's wrong, then you'll just get the failed results. Put this within your CI/CD pipelines, and basically you should be able to have a very robust system, like even for your SAS functionalities and logic. Okay, so I'm going to end off soon. I just want to touch on a little bit more about trigonometry in CSS. So this one actually has been a long time in waiting. You can see over here, this is a screenshot of the GitHub page for the CSS working group. They actually talked about trigonometric functions being implemented. This is all the way in 2018. We're almost 3 years in now. Unfortunately, today, I believe it's still not supported. Like I've looked around, there's no news on this. So it should come one day, but probably this is not something that's prioritized right now. But hopefully, yeah, as it comes in one day, we can be able to use this for different use cases, you know, not having to implement it in your SCSS style sheets, or maybe if you're using CSS in JS, not having to compute that in JS. Okay, I've reached the end of my sharing over here. So yeah, if you're interested in seeing like the full write-up of the entire thing of what we did, you can actually check out the Medium post over here. If you have more questions, you want to reach out to me on LinkedIn or GitHub, to like just follow me on that link over there. And yeah, that's all I have. Okay, I'm going to take a look at the questions. Oh, hi, Eric.
Hi. Okay, good talk. A lot of brain exercise.
Yes.
I see a lot of comments are talking about math. Right. Let's go from the top. Okay, shall we?
Okay.
Eddie Go asks, is Lottie files free? I think it is, right?
Yes, at the point when I used it, it's free. Okay, so I'm looking at the page right now. Yes, it's still free. Free. They put there free animation library. Yeah. In fact, yeah, I didn't pay a single cent. Like just now when I'm gonna Okay, this entire thing is like basically the asset is all this is out there. The JSON itself, of course, you have to create it yourself. You can use their online editor, or I think Photoshop is also doable. So this at this point in time, I didn't pay any money to get this thing out. Yeah, this is free.
And just a question. My question: the JSON is essentially like a CSV file, right? But for Lottie files.
Yes.
How does it look like?
Let me see if I can just paste this here. Quick show. Yeah, it's basically just this. A lot of stuff that we don't understand, but I mean, this is not meant for us to create like manually lah. You have to use the what's that? Their editor or use Photoshop. I think there's some way to export it using Photoshop.
Interesting. Okay. Next question. What is this GDG? Yeah, I'll answer that. GDG is a Google developer group. We have talks, workshops, and conferences for developers and also non-developers because it's not all just fully tech, right? Kojun says at least no one started talking about math in BE yet. Maybe we should do a talk about implementing complex math in the BE.
This is actually quite fun, to be honest. When I did this, like usually you don't get a lot of this like very complicated stuff, like even more so for front end. But I think it's the beauty of it, like when you want to stretch your, like in our case, we want to optimize our application. We don't want to go for like GIFs and all that. This really was a very good like weekend exercise too. Like we did it over the weekend on our own. In fact, we didn't. This was not part of company time, but it was really fun to bring this up as part of like side project.
I think like especially the web with web appearing on so many devices, right? So like those Nokia dumb phones could probably even run this if it's small enough.
Yeah.
Right. There's the KaiOS with the new KaiOS stuff.
As long as it supports the basic animation attributes as well as the I think in this case actually there isn't really the generated CSS is basically just like calculated lengths of each of the side. It's even for old phones should be able to support most of these.